All right, this is Unit 5, Lesson 1, Nth Roots, Radicals, and Rational Exponents. So in this lesson, we're learning how our exponents and radicals used to represent roots of real numbers. And at the end of this lesson, we'll be able to relate roots and rational exponents and use them to simplify expressions and solve equations. All right, so example 1, find all real nth roots. What are all the real cube roots of 125? So an nth root of a number c is x, such that x to the nth equals c. An nth root can be denoted by a radical symbol with an index of n. So this little n here, that's called an index. So my radical sign, so this radical sign, the n is the index. Usually when we're talking about radicals and indexes, we're usually dealing with an index of 2 or a square root. So that's called a radicand. So the index is n. This actual symbol is called the radicand. To represent the real cube root of 125, I write x equals 3 is my index, radicand 125. I find the values of x such that x cubed equals 125. To solve x cubed equals 125, I can note that 5 cubed is 125, so 5 is a root. I can also consider if there are others. Recall that complex solutions to polynomial equations come in pairs, so the number of real roots depends on the degree of the equation. So odd degree times odd number of real roots, and even degree, even number of real roots. So to determine this, I set the expression equal to 0 and I factor. So x cubed minus 25 equals 0. X minus 5 times x squared plus 5x plus 25. X minus 5 equals 0. Gives us the root of 5. X squared plus 5x plus 25 equals 0. The discriminant of the expression is 5 squared minus 4 times 1 times 25, or negative 75. So the roots are not real. Therefore, 5 is the only real cube root of 125. So what are all the real fourth roots of 16? So the index is 4 and the radicand is 16. I write x equals the fourth root of 16. I find the value of x such that x to the fourth equals 16. I set the expression equal to 0 and I factor. X to the fourth minus 16 is x squared minus 4 times x squared plus 4. X squared minus 4 can be factored as x plus 2 times x minus 2, and x squared plus 4 equals 0. So I get x equals 2 and negative 2. X squared plus 4 equals 0 leads to imaginary roots. So the real roots of x to the fourth equals 16 are 2 and negative 2. So the radical symbol represents the positive principal root. All right, so let's try it. Find the specified roots of each number. I want to find the real fourth roots of 81. Okay, so this I want to find. Here we are. So it's under basic. Here's my square root. So this is fourth root. My index equals 81. So x to the fourth. Okay, so x to the fourth minus 81. So that gives me x squared. Okay. Gives me x plus 3, x minus 3, x squared plus 9. Okay, so this will give me roots of plus or minus 3, and x squared plus 9 will give me imaginary roots. So plus or minus 3 are my real fourth roots of 81. Negative 3. And I'm finding the real cube roots of 64. So cube root of 64. So that's like saying x cubed equals 64. So x cubed minus 64 equals 0. And that's what I want to factor. That gives me x minus 4 times x squared plus 4x plus 16. Okay, so x equals 4 as a root. And since I wanted real roots, when I do this, x squared plus 4x plus 16, when I actually solve that, they're not real. So when I use the discriminant, which is, so this gives me 4 squared is 16 minus 4 times 1 times 16. So yeah, no. Zero. All right, example number 2, understanding rational exponents. So what is the meaning of the exponent in the expression 16 to the 1/4? So to interpret a rational exponent, I look at what happens if you extend the properties of integer exponents to rational exponents. So I assume the power of a power property applies to exponents in the form 1 over n. So 16 to the 1/4 equals 2 to the 4th times 1/4, which equals 2, which equals the 4th root of 16. So 16 1/4 is a number you raise to the 4th power to get 16. This means you can define 16 to the 1/4 to be the 4th root of 16, or 2. So basically, they're taking this bottom number, this 4, and that becomes the index in your radical. So in general, for positive integers n, x to the 1/n is defined to be the nth root of x. So x to the 1/n equals the nth root of x. So again, this denominator of your fraction, which is your exponent, becomes your index. So both the exponent 1 to the nth and the radical symbol, the nth root of x, indicate the principal nth root. So what is the meaning of the exponent in the expression 27 to the 2/3 power? So 27 to the 2/3 power is 27 to the 3rd squared. So I'm going to take the cube root of 27. So again, this denominator becomes my index, and then I'm going to raise all of that to the 2nd power. So the cube root of 27 is 3, 3 squared is 9. So this means that you can define 27 to the 2/3 power to be the cube root of 27 squared, or 9. So I want to explain what each fractional exponent means, then evaluate. So 25 to the 1/2 power. So this means a square root of 25. So remember, equals 5. So this is really, this 2 is really up here in the index, so it's squared. So 25 to the 1/2 equals the square root of 25, which equals 5. Then I have 32 to the 2/5. So that means the 5 goes here in the index 3, and then I'm going to raise all of this to the 2nd power. So the 5th root of 32 should be 2. Yep. So 2, and then 2 squared equals 4. All right, so concept, interpreting fractional exponents. The index of a radical is equivalent to the denominator of a fractional exponent. So in general, if the nth root of c is a real number, the nth root of c equals c to the 1 over nth power. Furthermore, if m is an integer and m over n is in the lowest terms, then c, m to the nth, equals c to the 1 over nth to the mth power, equals the nth root of c to the mth power, and the nth root of c to the mth power equals c to the mth to the 1/nth equals c to the m over nth. So example 3, evaluate expressions with rational exponents. So evaluate the expressions 32 to the 3/5, 27 to the negative 2/3, and 50 to the 3/4. So 32 to the 3/5 equals 32 to the 1/5 cubed, which is 32 to the 1/5 is 2, so 2 cubed is 8. 27 to the negative 2/3, 27 to the 1/3 to the negative second power. So 27 to the 1/3 power is 3. 3 raised to the negative half, negative 2 power is 1/9. Because 3 squared is 9, and then it's negative, so we flip it. Since 50 does not have a perfect fourth root, I use a calculator to approximate 50 to 3/4, which is approximately 18.80. The Fujita scale rating F of a tornado is represented by F equals the cube root of W over 14.1 squared minus 2, where W is the estimated wind speed of the tornado in miles per hour. What is the Fujita scale rating of a tornado with estimated wind speeds of 100 miles per hour? So I substitute in 100 for W, which gives me F equals the cube root of 100 over 14.1 squared minus 2. Okay. I can rewrite 100 over 14.1 to the 2/3 power minus 2. This gives me 7.09 to the 2/3 minus 2, which gives me 13.69 minus 2, or 1.69. So a tornado with estimated wind speeds of 100 miles per hour is classified as F1 according to the Fujita scale. So what is the value of each expression? Round to the nearest hundredth if necessary. So I have negative 16 to the 3/4. So this is the fourth root of 16, and it's all going to be cubed. So this gives me 2 cubed, which equals 8, and there was a negative out in front, so negative 8. Okay. A fifth root of 3.5 to the 4th power. So this is like saying 3.5 raised to the 4/5 power, which equals, handy dandy calculator, 3.5 raised to the 4/5, which gives me 2.72 approximately. You can also do it here. Check your answer, approximately 2.72. All right, example 4, simplify nth roots. I simplify the expression, the fifth root of 32m to the 15. All right, so I write the radicand as an expression to the 5th power. So I know that 32m to the 15 can become 2 to the 5th becomes 32, m cubed to the 5th becomes m to the 15. So 5 and 5, they cancel each other out, so I'm left with what's underneath the radicand, which is 2m cubed. So the fifth root of 32m to the 15th equals 2m cubed. All right, so I want to simplify the expression. The fourth root of x to the 20th, y to the 8th. So again, I rewrite the expression to a radical with a 4th power. So 20 would give me 5 to the 4th. 8 becomes 2 to the 4th because 2 times 4 is 8 and 5 times 4 is 20. So this is the absolute value because it's an even root. So the absolute value of x to the 5th y squared. So the absolute value of x to the 5th y squared, because this is going to be a positive number anyway. Okay, so to recall that the y squared will always be positive and does not require the absolute value, but the x to the 5th could be negative. So like if you had negative 2 to the 5th, it would give you a negative 32. So you want to make sure that those absolute values are there for odd powers. Okay, so I want to try it out. Simplify each expression. The cube root of negative 8a cubed b to the 9th. So again, I want to rewrite this. So it's raised to the cubed power, or third power, so 3. Okay, so I want to rewrite this. So this becomes negative 2 cubed, gives me negative 8. a b cubed. This is all raised to the third power. Oops. Okay, so this gives me negative 2ab cubed. Okay, so negative 2, remember, that would still give me the negative 8. Negative 2 cubed does give me negative 8. So negative 2ab cubed, it becomes my answer. I have the fourth root of 256x to the 12th, y to the 24th. So again, I want to rewrite this with an index of 4. Okay, so 256. So what is 4? So 4 to the 4th. X cubed, because 4 times 3 gives me 12, and y to the 6th. That's all raised to the 4th power. So 4 to the 4th is 256. X cubed times 4 is x to the 12th, and y to the 6th times raised to the 4th power is y to the 24th. Okay, so this is the absolute value of 4x cubed y to the 6th. Or you could also write it as 4x cubed y to the 6th, because again, the x cubed is odd. So I could potentially put a negative number in there, and that would actually change my solution because it's a 4th root. So I need to make sure that that's in absolute values. The rest of them I don't have to. You can leave them in absolute value. It's still technically the correct answer, but really the only one that needs to be an absolute value is x cubed. Again, I don't have to worry about that up here with a cube root. All right, example 5, use nth roots to solve equations. So I solved the equation 2x to the 5th equals 64. You do this just like you would any other equation. I'm going to divide both sides by 2 to start, which gives me x to the 5th equals 32. I raise each side of the equation to the 1/5 power, or you can take the 5th root. It's the exact same thing. 32 to the 1/5 equals 2. This is actually easier just to put in your calculator. So the solution to the equation is x equals 2. All right, so let's solve the equation 5x cubed equals 320. So I'm going to divide both sides by 5. Okay, so this gives me x cubed equals 64. So this is like saying so that's all that's saying. So x equals 4. And cube root, so I don't really have to worry about anything. Solve the equation 2p to the 4th equals 162. I divide both sides by 2, which gives me p to the 4th equals 81. It's 81. Okay, so I'm going to take p to the 4th, and I'm going to raise that to the 1/4 power. And that's like saying 81 to the 1/4 power. So 81 to the 1/4 power gives me 3. So p equals plus or minus 3. And I can say that it's plus or minus because if I multiply -3 times -3 times -3 times -3, I still will get a positive 81. Whereas up here, the x equals 4th, that's the only way that I can get a positive 64. If I were to multiply by -4, I would get negative 64, so it wouldn't give me the correct answer. Okay, so when I'm solving and it's an even exponent, I have to include that plus or minus because either of them could be the correct answer, but if it's odd, I only include the one that I get. All right, so concept. Solving an equation in the form x to the nth equals c. To solve an equation in the form x to the nth equals c, I find the nth root of both sides by raising each power to the 1/nth power. So x to the nth minus to the 1/n equals c to the 1/n power. All right, example 6. Use nth roots to solve problems. So one cube-shaped container has an edge length 2 centimeters longer than the edge length of a second cube. The volume of the larger cube is 729 centimeters cubed. When the larger cube empties into the smaller cube, how much water will spill? So we see, here's my 729 centimeters cubed, and it's going into a smaller one, and I want to know how much this water is going to spill over. So I can recall that the volume of a cube is s cubed, where s is the length of the side. If x is the length of the side of the smaller cube, the side length of the larger cube is x plus 2. So remember, it said up here, one cube-shaped container has an edge length 2 centimeters longer than the edge length of the second cube. Okay. So smaller cubed is x plus 2. The larger cube is x plus 2. So I'm taking x plus 2. So x plus 2 cubed equals 729. So I substitute x plus 2 for s and 729 for the volume. I raise each side of the equation to the 1/3 power and I solve. So I get x plus 2 cubed raised to the 1/3 equals 729 to the 1/3 power. So x plus 2 equals 9, x equals 7. The volume of the smaller cube is 7 cubed, or 343 centimeters squared cubed, and the volume of the larger cube is 729 centimeters cubed. So the amount of water that spills is 729 minus 343, or 386. So when the larger cube empties into the smaller cube, 386 centimeters cubed of water will spill out. Okay. So one cube has an edge length 3 centimeters shorter than the edge length of the second cube. The volume of the smaller cube is 200 centimeters cubed. What is the volume of the larger cube? Okay. So one cube has an edge length 3 centimeters shorter than the edge length of the second cube. So that's the smaller cube. So x minus 3 cubed equals 200, because that's the smaller cube. That's what we're given. So in the previous one, they actually gave us the volume of the larger cube, which is why we did the x plus 2. Here we were given the volume of the smaller cube, so it's x minus 3. Okay, so now I'm going to raise x minus 3 cubed to the 1/3 power. I'm going to raise 200 to the 1/3 power. Okay, now, this is probably not going to be a lovely, nice, even number. No, of course not. So I get x minus 3 equals, so this gives me 5.848. Okay, and then I'm going to add 3 to both sides. So plus 3 gives me, so x equals 8.848. The volume of the smaller cube, what is the volume of the larger cube? So the larger cube is 8.848 cubed, or approximately 692.69 centimeters cubed. This was the volume, the side length of the larger side, remember, because we subtracted, so the 5.848 was the smaller one, which gave us the 200. So the larger one is 8.848 approximately. And I cube that, I get 692.69 centimeters cubed. All right, so concept summary. Nth roots, radicals, and rational exponents, relating radical and exponential forms. So in words, the index of a radical is equivalent to the denominator of a fractional exponent. The exponent of the radicand is equivalent to the numerator of a fractional exponent. So in numbers, in radical form, the fifth root of 32 to the fourth equals 32 to the fourth raised to the 1/5 power, or 32 to the 4/5. In exponential form, 729 to the 5/6 power equals 729 to the 1/6 to the 5th, or the 6th root of 729 raised to the 5th power. So in algebra, radical form is the nth root of c to the m equals c to the m to the 1/nth equals c to the m(nth). An exponential form, c to the m(nth) equals c to the 1/nth to the nth equals the nth root of c to the m. Okay, so solve an equation in the form x to the nth equals c. To solve an equation in the form x to the nth equals c, I find the nth root of both sides of the equation by raising each expression to the 1/nth power. So x cubed equals 1,728. So it's like saying x cubed to the 1/3 equals 1,728 to the 1/3 power, which gives us x equals 12. So the third and the 1/3 cancel, leaving us with just x, and the 1/3 power of 1. So it's like taking the cube root of this gives me 12. In algebra, x to the nth equals c, so x to the nth to the 1/nth equals c to the 1/nth, or x equals c to the 1/nth. All right, so that is the end of lesson 1. Go ahead and work on your homework.